So yeah, the organisation I'm running today is Build Test Solutions, and we develop novel tools and techniques for measuring building performance. So our underlying mission is to try and make measurement more commonplace. Why aren't we testing, verifying, signing off buildings writ large? So yeah, you've referred to Pulse as with one product we have, a means of measuring air-tightness. We've got a whole suite of other products around measuring heat loss and U values and ventilation performance and so forth that I'm sure we'll come on to. In terms of how have I got to where we are today, I think probably my earliest sort of career-related memory would be sort of around the time of my A-levels, being pretty steadfast that I didn't want an outright office-based job, like pretty basic kind of thing, but I knew I wanted to do something that was between office and yeah, so something out in the field would be a bit more hands-on. My youth would have always been sort of mending bikes and making and doing and Legos, Technic sets and what have you. So yeah, I've always been a pretty practical kind of hands-on type of person. I initially, post A levels, signed myself up for undertaking a degree in construction project management. I have no real idea why. I kind of being again that thing of being on site, sort of a cross between some office-based the project management skills as well as being out on site, hands-on, making sure stuff gets done and done properly. Really interested me, I guess. But before I did that, I deferred a year and I opted to. There's a brilliant program called Year in Industry, and it facilitates companies joining up with fresh-faced college students to give you a year in industry work experience. And I landed myself with Jacobs Engineering and their geomatics team. So yeah, straight out of college, I was straight onto a theodolite and out measuring all sorts, mostly kind of utility pipelines and cable runs and some wastewater treatment works and that kind of thing. But again, that kind of reaffirmed to me that this idea you can actually have something that requires a bit of intellect and you're office based and you're doing some CAD based stuff as well as you can be outside enjoying the fresh air and hands on. And fairly last minute, I changed my degree registration to then I decided instead I wanted to do architectural technology. And so off I went, Preston University, and embarked on a 3-year sort of degree in architectural technology. And again, the same thrust was still there. It's kind of I want to understand how buildings work. It's that cross between kind of architecture and structural engineering. And right from the off, even though I never had that really, really clear drive, it's got to be building construction related, but right from the off, the bit that really, I guess, engaged me the most was the whole sustainability, energy efficiency piece. So when we were thinking about specifications at uni and doing these kind of projects and conceiving these new buildings and refurbishment kind of things, it was all about sort of I put a huge emphasis on whether it's understanding the embodied carbon aspects or, just the operational efficiency or just the detailing and thinking about air barrier and insulation continuity and stuff. So right from the off, as much as I could have gone all sorts of different directions with architectural technology, the energy efficiency, sustainability piece really, really caught me from the off. And then from there, I was really lucky to land my first job was what's known as a KTP, a knowledge transfer partnership. So for anyone watching this who's not familiar with that as a program, it's backed by Innovate UK, and it's particularly well suited to sort of SMEs, smaller companies, to be able to effectively take on a sort of high-performing graduate and almost run it like a graduate program, but it's kind of self-directed by the graduate to solve a specific problem with a bit of funding support from Innovate. So I was successful in securing one of these knowledge transfer partnerships with a company called Fusion 21, who are a social enterprise in Liverpool, Merseyside. And they do procurement frameworks for social housing providers. And the academic partner of this KTP, because that's the other part of it, was the University of Salford. And the brief was to support Fusion 21 and its members who procure from its frameworks to create a retrofit investment decision-making tool. So how can we, I think it was about 10 or so housing associations at the time, which would have been managing probably over 500,000 homes between them nationally. How can we help them look at the existing EPC and stock condition data that they have and run it through some kind of model or simulation tool to evaluate what upgrades might be applicable. So get a bit of a baptism of fire, sort of this broad brush kind of architectural technology into retrofit and being kind of self-directed, it really quickly getting under the skin of it. And kind of the biggest feature of this decision-making tool that we built was what we called a risk table. So really trying to appreciate the interconnectedness of measures. Like if you do external wall insulation, consider the implications on the positioning of the windows in the reveals, or consider the risks around ventilation and moisture. And so yeah, again, really just in the thick of it from the off. And then the partnership with the University of Salford then meant I was supported by academics over there. I think Richard Fitton and Will Swan were both really supportive of sort of me undertaking that programme, and have been really instrumental in a lot of the direction my career's gone in, really. And they obviously had the Energy House facility, and that exposed me to this Victorian terrace and the environmental chamber, and then all the really interesting experiments that they were doing, measuring performance. The insulation says it's going to do X when applied to the wall. Put heat flux plates on that and measure it. Does it actually perform? And if not, why not? And again, so that really struck a chord in the sense that it's going back to that. So still some desk-based stuff, but being hands-on with instrumentation and a bit engineering-y. From there, so that was a 2-year program. Loved it. Totally immersed in retrofit. Like that was it. My career was set. And I did a short stint. This would have been around 2012, 2013. A short stint in London with the Energy Efficiency Partnership for Buildings, which was this kind of quasi-government industry body. A bit kind of left field, I guess. It was kind of working with them, supporting them on a technical basis around how you put in place sector-specific strategies. So I worked on the microgeneration strategy with the Energy Saving Trust. And I was looking at this idea of how might you replicate the zero carbon hub that was thriving at the time in retrofit and create a retrofit hub. So I worked on that, and that was brilliant for my general network, being exposed to the great and the good across these different market segments. And it was a time when industry and government were working quite closely and working quite well. Then I don't know if you remember, but it was kind of this, it was referred to as the bonfire of the Quangos, this kind of, that didn't want, this kind of absolution of any kind of, quasi-government industry bodies. And so the funding for it all was just pulled, and some really great working groups and things were just, gone overnight, and all the strategy documents and all sorts. So then from there, I found myself at the National Energy Foundation, which is a charity based in Milton Keynes. It was an opportunity to get out of London and put our foot on the property ladder. So my partner and I at the time, it was our first sort of purchasing our first home. It would have been rude to buy anything other than a wreck of a house that we wanted to do retrofit. Up and retrofit. Yeah, so which I couldn't advocate any more if I'd tried. Kind of, I think it really stands out to me, the people in industry who've been through it themselves, whether it's built their own home, retrofitted their own property. yeah, I think they're just so much more authoritative and speak from experience on all things sustainability, energy efficiency. It really stands out for me. So yeah, if you got the chance to do it, you really should practice what you preach. So yeah, I did a stint with the National Energy Foundation, and that was more of a traditional technical consultancy role. So supporting social housing providers again with their kind of sustainability strategies and doing lots of stock modelling. But this is where the building performance measurement kind of strand kind of started to kick back in. So at the time, Innovate UK were running a £8 million building performance evaluation programme. It was about 120, 130 buildings that had all bidded into this fund, put themselves forward to basically commit to doing building performance evaluation, monitoring, and testing the buildings. So they sort of signed up to this. They knew they were involved as the design teams or consultants on new build projects, both residential and non-domestic, and signed themselves up to, we're going to use some of this funding to measure and test these properties. And through the consultancy piece I was doing with the National Energy Foundation, I was exposed to the delivery of some of those projects, and I was also exposed to then the follow-up evaluation of all of the data. And there's some great reports out there, but some headline findings were around this idea of the performance gap. So just in headline carbon emissions, both residential and non-domestic buildings, the as-delivered, as-built so properties were consuming 2.5 times what was modelled. And so it's like, this isn't right. Like it's madness to have Part L slowly kind of turning the screw and making the design standards ever more stringent. And yet, no matter how stringent they are, the reality on the ground is you're delivering wide of the mark. So you think on paper, we're heading towards net zero and gradually making buildings more energy efficient, but are we actually, are we interested in sort of 80% reduction by 2050 in theory, or does it have to be delivered in reality? It has to be delivered in reality, of course. So then one of my projects with the National Energy Foundation was this opportunity to put together a consortium and work with the University of Nottingham on this concept of what today is known as PULSE, with compressed air-based method of measuring air tightness. So we delivered that project, and it was a 2-year initiative with some great partners, ran its course, and we felt this technology has legs, we want to take it into the market. The university would only license the IP to a single entity. So it was effectively my brainchild to come up with this kind of joint venture vehicle, this new company called Build Test Solutions. And it's an intentional play on words. It's not Pulse Air Testing Limited, or it's not a one-trick pony. We want to do exactly the same as we have just done with the University of Nottingham, with the Pulse technology, pulling it through to a product to take to market. How can we build more testing solutions? How can we get those solutions for testing buildings into the market? And it's all around just recognizing that we need to be measuring more, and only by measuring do you close that feedback loop. And so, that's kind of, it sets our mission to make measurement mainstream, and we've gone about doing exactly that, kind of working with other universities, like-minded innovators, to try and pull through various other tools and techniques for measuring. And it's not us out there providing measurement services, it's us developing the tools as the manufacturer, essentially, to empower others to measure. Because we want to be measuring every building, and we're not going to do that. It's called that multiplier effect.
So would Nottingham University commercialise this project, or did it mean that or were you the only reason why, or were you the reason why this actually was commercialised?
I believe the concept had been the subject of a student's PhD some years prior to when we came along with this. The Innovate UK competition was called Scaling Up Retrofit. And so, before we conceived the project around that funding call, I believe it had been, as an idea, published PhD thesis, sat on the shelf for some time, a good kind of 5 or 6 years or so. So, certainly when we approached them, they weren't actively kind of seeking to commercialise it. And I think even after the Innovate UK 2-year project had run its course, if we had said, no, don't think we fancy kind of setting up any kind of license with you guys, it's a shame, but I think it probably would have then just gone back on the shelf. So it really does require that someone to have the bit between the teeth and say, it's such a, people to refer to it as a technology valley of death. It's like, it's all well and good having a nice idea. Is there the need for it in the market? And if there is, how do you get it there? How do you productize that idea, make it kind of go through all the regulatory hurdles and product development, big investment required to turn it into a product. And we had the challenge of the blower door fan as a technique for measuring airtightness, which is a perfectly valid, workable tool. Has been around since the 80s. Has been the only show in town since the 80s for measuring airtightness. And so over the course of that product's life, international standards have been written around it, have been written into the building regulations. So it's really difficult as an innovator to come in and say, we're not saying throw that in the bin and it's got to be our product. It's just, here's another option, another choice, different features and benefits. And we had to do, a massive piece of verification of the technology. How does it perform against the incumbent? Is there any particular bias with one or the other, or do they give the same result in the same house?
So how does Pulse work then compared to the blower door system?
So Pulse is a compressed air based method. So rather than mounting a fan in a doorway, you sort of your temporary canvas, and you're either pressurizing or depressurizing. Pulse is an aluminium canister that we pressurize to 10 bar, 125 psi, with a portable compressor. Takes about 7 minutes to charge the tank. So in those 7 minutes, whilst it's charging up, you would do your building preparation. So
you should tape it.
Yeah, exactly the same preparation as the blower door test. Internal doors open, external windows and doors closed, trickle vents closed, temporary seal up, purpose provided ventilation. And then the test itself it's essentially a push button test. So you input the building envelope area and volume, press go, and essentially what happens is the system, we sample the background pressure for a couple of seconds, so to get a baseline, understand what's going on in the sort of ambient conditions. The valve then opens full bore, releases a burst of air which creates a spike in the background pressure. It would normally top out at around 10 pascals, something like that. So even if you're stood 2 meters away from the unit, you don't even feel the air. It's like it just has this kind of knock-on sort of reverberation effect, if you like. So the burst of air just propagates through, travels at the speed of sound, so sort of very similar to acoustics. Sort of instantaneously pressurizes the building. And we're not interested in the absolute peak. What happens is the pressure rises in the building, and then even though the valve is still open full bore, the pressure then starts to drop off, the background pressure in the building. And there's a phase in that pulse shape that the academics refer to as the quasi-steady state. So the flow out of the nozzle becomes equal to the flow out of the gaps and cracks in the building.
Okay.
So the valve is only open for 1.5 seconds, and we're probably only using sort of a tenth, 2/10 of a second of data in that. Then the valve closes, a little bit of inertia, and then we sample the background pressure again for a couple of seconds afterwards. So start to finish, you're 12 odd seconds in total.
And so just for context here, just give me an idea of how much time it would take for a test to be done under a blower door?
Yeah.
So don't worry about the setup. So
Sure.
when the setup's done and everything, just kind of like that period of time where air is being input into the space and the measurement is being taken.
Sure. Yeah. Once fully rigged, running a blower door test, you're typically taking 7 or 8 readings across a range, 10 minutes or thereabouts, perhaps, to go through your readings. The gauges for blower doors are increasingly smart and will automate that process. I guess for passive house, for instance, it's required actually that blower door you both pressurize and depressurize.
Right.
So you'd flip the fan around
Yeah.
and then go again another 10 minutes or so. And that can be quite insightful and quite instructive in terms of, on one hand, you're pushing the building fabric, pushing window seals out, pushing the loft hatch up. Depressurization, you're sucking membranes inward and sucking the window seals inward. So it's not unusual to get quite different results from pressurization and depressurization. So yeah, pulse, there is a time saving. You're down to a matter of seconds rather than that kind of 10 minutes of taking readings. I think there's also a lot to be said for how much simpler it is to operate. Less can go wrong. It's a self-contained unit. Like I say, push button test, get your result read out to you on the screen. And yeah, I think where we're finding particular traction with the product is retrofit. So it's also that bit less invasive, testing an existing occupied home. You're not bolting a bloody great fan on someone's front door and sucking the heat or blowing a gale into it. So yeah, it's what everyone will call us out on is blower door, fantastic for doing leakage diagnostics. Leave the fan running, go around with a thermal imaging camera, or even feel it with the back of your hand, kind of feel where air's coming in. Pulse being that short, sharp burst of air won't do that. But as a compliance test, get your result at the end of the process, or a sign-off test. Yeah, so it's a pretty good tool.
So a really daft question here. Is there a way that you can open the valve but with just less pressure so that you've got that like for like, so you've kind of almost got a bit of a trickle this going out to cover that? Because I know that when we did as a consultancy air testing, we found that was problematic for us. But this was, I think, probably when it was first out. I don't think it was out in the market, so this is a long time ago.
Yeah, I think there's a few different ways of looking at it. So we are about actually to sponsor a PhD with the University of Nottingham, have a student look at the data that we've amassed in recent years. So we're probably running at about 170,000 pulse tests having been conducted.
Okay.
So we've got a really nice data set there, and we're convinced through machine learning and a bit of sort of AI we can understand a bit more about the pulse shape and sort of what can we infer from how quickly it decays, or could it tell us a little bit more about the nature of the leakage paths that we're dealing with, perhaps? Could it perhaps operate at a lower pressure or shorter valve open time? Could we make the whole kit that bit more compact, perhaps? So that's one thing in our sights on kind of a sort of medium, long-term development path. On the diagnostics, I don't think you could... Yeah, it's not immediately obvious that you would just leave the valve open longer and be able to then quickly whip around and feel for leaks. I think there's a bigger cultural thing at play here where, sort of particularly new builds where air tightness testing is required under Part L for your compliance sign-off, it is frankly seen as a compliance tick box at the end. And if you're failing at that point of like the CML phase about to start, or exchanging tomorrow kind of thing, and it's failing, as much as blower door is fantastic for doing diagnostics, you are not addressing the primary air barrier when you are at that kind of point in time. And it's a sad fact, but people are going around with a mastic gun or temporarily sealing up, and we'll get the result by hook or by crook. And so, is it helpful that Pulse could do that diagnostics at the end? I'm not sure it is. So a complementary product we have to Pulse is Leak Checker, which is people might snigger, but it is a mini blower door fan designed to be window mounted. But we're retailing that at just shy of 1,500 quid, and it's targeted at site teams to rig in a window during the construction phase, to run it at first fix, run it it's after certain stages when certain tradies have been in, and address the air barrier before it's covered up, or before you're putting in final finishes. And I think there's a lot to be said for that. It's kind of this, or is that, or this idea of intermediate testing. People just accept that you're doing a pre-compliance test and then a compliance test at the end, perhaps.
Yeah, I agree. We've seen that over the years. People going around with a mastic gun. The most dramatic story I've got is we were working with an organisation and they were doing their first net zero properties. And there was a group of properties. I'm not going to say how many because I don't want to expose anybody. But they were getting 8 on the air test. And it took us a while to help them understand the need for it not to be 8 and how you were not going to get a net zero building as kind of designed. You know, that gap between this is what has been designed to this is actually how we're performing. And it came down to the way that building was put together and was managed and all the rest of it. It was not done in the right way at all. So they got it to an acceptable level, but I know that there are a group of houses in the country that have got net zero written on the whatever, but that really aren't, because as you know, over time that mastic and the performance of that building changes. And that's the sad thing, because they were, and I was really hopeful that they were fully embracing what they could do, because they spent a lot of time and a lot of effort, and we spent a lot of time and a lot of effort with them getting this to that right stage. But that was just the design. But in that construction element, which is what you're referring to here, that was just, it all fell down, and all the wheels came off of that organization. They were up in arms. You know, you need to do this, you need to do it. Then they tried to make it like our problem. It's like, it's not our problem. We're here to help you. But that's the downside of the mastic. And so maybe if anyone's listening to this and they think that actually what I need to do is just get this air permeability to this area, and my get out of jail free card is mastic, to me it's like putting lipstick on a pig.
I think, to be fair to industry in the round, what's been great is that airtightness came into the building regulations. I think initially it started to be referenced in 2006, 2007 time, and then it was sample-based requirement from 2013. And then, slowly things have cranked up, and now it's 100%. Everything needs a test before it can be signed off, and that has led the industry to learn. And I think if you went back 10 years and compared that to where we are today, developers are readily achieving an air permeability of 4 or 5 without trying too hard. Like just tradespeople, subcontractors, they get it. We understand the value of toolbox talks, and detailing has been worked through so many times now that it is deliverable and repeatable. So I think if you asked seasoned airtightness testers, the failure rate has generally kind of dropped off. Probably still around kind of 10% sort of failure rate, perhaps. What's interesting is then the future home standard comes in again soon, and we'll tighten the screw that a bit more. And then maybe it's that actually an air permeability of 4 or 5 is relatively easy to achieve, but having to get to 2 or 3 is another story again. Passive house is another story again. But then there's some great products coming on about sort of liquid applied membranes and some fantastic airtightness tapes and all of this grommets and stuff, making site teams' lives easier. Off-site construction, get it right in the factory before putting it on site. So only by measuring do you learn? You have those sort of squeaky bum moments on site. Bloody hell, how are we going to fix this? Lastminute.com. But hopefully the developer learns from that and it doesn't happen again on the next site, and you slowly improve. And this is what we're kind of driving at more generally with build test solutions, is that you can't manage what you don't measure. And you look at any other industry, automotive, aviation, electronics, there's a really clear kind of sort of train of individual components and products will be tested, bench tested, and signed off on. Thinking about a car, so
quality checked as well.
Yeah, suspension, springs, tyres.
Yeah.
Every individual element has its own test protocols on it. Wheels its way down the production line, pieced together. It comes together as a complex system of parts, and then it's put around a test track. It's put through its paces in all sorts of weird and wonderful ways. And then actually you have traceability once it's even into the supply, sort of into the showroom. And it's not uncommon for sort of car manufacturers to do recalls and identify issues with certain production batches and all the rest of it. I think in construction, built environment sector in general, we're reasonably good at the product testing piece. So you hear about the UCAS labs and all the sort of British and European and international standards around how you test the sort of density and thermal conductivity of blocks and insulation products and the individual component parts. I think what we massively overlook is that buildings are actually really quite complex systems. All these parts come together to create a home or an office, and there's so many factors at play. That you've got the quality of workmanship, you've got the risk of product substitution, you've got the weather being built on site, all these different subcontracts, so many different variables, and yet frankly I think that our building control model is broken. It's like if you're lucky, you'll visually inspect at certain stages and sign off based on what you see, and invariably building control are mostly interested in structure and fire. Do they really take a close look at like the continuity of your insulation in your slab and your upstands and how that feeds into your walls and the junction of the sort of windows and walls to roof, all those critical thermal bridges and just overall insulation continuity? I don't think they do. And so then you have a completed home or completed retrofit or whatever it might be, and we don't close the feedback loop. We don't have products or systems, processes in place to test, verify, sign off, learn from. And so that's as much as we can talk about pulse and airtightness, it's like, just how do you do that in the round? How do you create tools that are accessible to your building control inspectors, your building surveyors, your energy assessors? They can go in, boots on the ground, do a point-in-time test, sign off on these buildings. So that, because then otherwise you've got all this kind of carry-on around defects and disputes and reputational damage around quality and performance.
100%. And I think that the closer we get to the future home standard, the more problematic that could be. But I guess the thing that stands out to me is that it is a new thing, as you said, but also there's a bit of a lack of understanding of the benefits of what to do and what not to do at certain phases throughout the build, so that when it comes to the air permeability, you are getting to 3 with ease, as opposed to getting to 5 with ease. But you're right, if you go back, 5 was a struggle. And I remember when 5 was a struggle for organizations. But I guess the disappointment is the not understanding the why. Why is it that I'm doing this? And then increasing of the ability of like, this is how you do it, because what you're left with at the end of it is a substandard product. So it's effectively having that new car roll off the forecourt, and then a few months down the line, the performance of that car being, I don't know, like something that was created 10, 15 years ago.
Yeah.
But you not knowing it.
Yeah.
But there's a small group of people that would be like,
Yeah.
your car's not performing that well.
Yeah. Can you actually game the process? Or the brochure for the car says you're going to get a combined efficiency of X miles per gallon or kilowatt hours.
Exactly right.
And are you actually getting that in reality? And I think, I mentioned the performance gap earlier, and I do think generally the industry is a bit frightened of it. I've heard it referred to me before as like Pandora's box. Like, do we want to open this and get into this? And you can readily, and I think people do, hide behind the complexity. So it's nothing to do with the workmanship or the products or the quality. It's all to do with the occupant walking around in their underpants with the window open, or that was a harsh winter. That's why the bills were high. Like, come on, take me to court and let's battle it out. There's so many variables here. You're not going to win.
But the other reason that no one would win is because the average occupant wouldn't know what is good and what should happen. So there's a guy that works for me who has recently bought a new build, and he has taken the contractor to court, or threatened to take them to court, and he's listed out all of the things that weren't right and what they should have been. But he knows, and he knows in detail, and there's no way in this world that the contractor is going to win because he knows.
Picked the wrong fight.
But he's an anomaly. He's not like he's not like my wife or my friends or any of your friends that are outside of the industry.
Absolutely. Yeah, I think there's.
Does that make sense? Because I'm saying, what I'm saying is, yes, we need to rip the lid off of Pandora's box and deal with all the stuff in there, because there's an opportunity to give an end product that is high standard instead of an end product that is of an okay standard, but that leaves the homeowner thinking something's not quite right. And I can't put my finger on it, and I can't prove it, so I'm just gonna have to live with it.
Yeah. I think there's actually a slightly more positive spin on this. Is that from our experience of measuring buildings, whether it's airtightness or actually headline, the heat transfer coefficient, the headline fabric thermal performance, or ventilation flow rates, or individual U values of elements, floors, walls, roofs. It swings both ways. It's not all about underperformance and let's beat up on the developers and the house builders, and they're all trying to pull a fast one. It's actually some measurement can also verify that there's some really good stuff out there, and I think that's what's overlooked a lot of the time is that actually it can showcase great work and be used as a marketing tool to say, like classic Ron Seal does what it says on the tin. Like we put our money where our mouth is, and we can assure you this is measured, verified performance. So we've worked with a number of the major house builders, and it's not that every time we measure them they're all terrible. It's a really useful way of. There are just one or two outliers occasionally for various reasons, miscommunication between subcontractors, or there's often good explainable reasons, and so it shouldn't be kind of something that developers or contractors run away from. It's a really useful quality management tool, a quality assurance tool, and marketing tool, and. Yeah, the Future Home Standard actually proposes this idea of or the consultation at least proposed this idea of a Future Homes brand sort of badge, Future Home Standard badge. And to achieve that, it's suggested that it would be a requirement to get that badge, albeit a voluntary thing, to do HTC measurements, heat transfer coefficient measurements. And so that would be this need to test the whole building fabric efficiency and sign off on it. And what's great about the HTC is that it's an assessment of the overall fabric performance. It's inclusive of the air leakage, the thermal bridging, the U values, everything in a number. So it's not, you have to wait a year and see what the energy bills are like. You can measure this thing in the space of 21 days. With co-heating tests, you can do sort of, typically 2 to 3 weeks, you get yourself a number. And so that's coming, and that will be a great way of some house builders being able to differentiate themselves from others being able to use it as let's do it sort of behind closed doors, sort of QA check and see where we're at, learn from it. And on retrofit existing buildings, it's really interesting. Like most models, RDSAP, PHPP, even dynamic simulation models, tend to use quite conservative input values from SIBSE lookup tables and so forth, that mean and this is quite a broad brush sweeping statement, but more often than not, when you measure the thermal performance of an existing home, it's better than might otherwise be predicted. So we've done studies looking at things like the heat loss calculations, 12831 MCS heat loss calcs done for heat pump sizing, and when you measure the heat loss, it tends to be less than what the calculation would have you believe. Similarly with EPCs, you think you've got a poor performing building. Actually, the peak heat demand is fairly modest. It's heat pump ready. Put some PV and a battery on that home, and like the investment case for insulation isn't necessarily there. So it can take you some pretty different directions with the measurement.
What's the future looking like for you at the moment with your organisation, with the testing, with what you're trying to achieve? And then obviously we've got the future home standard. We've not mentioned the future building standard yet. There's not that much detail on that, but what's the future like for you at the moment?
We set up Build Test Solutions in 2016, so we're approaching our 10th birthday. In those 10 years, they've been formative years. We've been very much kind of heads down developing this suite of measurement tools. We've got methods of measuring HTC. We've got methods of rapidly measuring U values, measuring air tightness, measuring ventilation. So there's no longer any excuse to not be measuring. A big piece of what we've also been working on is, like, frankly, we've got to make the market. It's not like there's a ready-made market and people are actively measuring regulations and requiring people to measure. So we've been doing a lot of that as well. So sort of Pulse is accepted is incorporated into Part L of the building regulations as of 2022. We're working with SIBSE at the moment on a new technical memorandum around heat transfer coefficient measurements, and trying to make sure that there's standardisation and clear agreement across industry there. We are working with the likes of Elmhurst and BRE on them recognising that in situ U value measurements are a thing and can be input into EPCs. And I think only once we get those kind of foot in the door with the regulations and acceptance that, these tools are viable. And it's so much more, it's beyond just the technology. It's all well and good having the technology, but you need to make sure that anyone who's using it is trained and competent and, like airtightness, submitting and lodging tests that are subject to audit. And I think that's the thing we're finding at the moment. There has to be a framework around these things. You can't just let people loose with the tools and they'll measure and get whatever answer they want. Not that doesn't happen already with visual inspections, and anyone can kind of make up the inputs. But working away on that. But then beyond that, the future I think is really exciting. We've touched on the future home standard, making reference to at least a voluntary requirement for HTC measurements. That's where airtightness started, and today we're at 100%. So that's the trajectory HTC's on in new build. I think retrofit, we're seeing the HTC measurements being used a lot in heat pump sizing, accompanying MCS heat loss calcs. We're seeing airtightness testing being used a lot there now as well. So airtightness sort of breaking out of the new build sort of channel and into more and more retrofit. With all sorts of other policy mechanisms being touted around I don't know if you're familiar with the energy company obligation, but that drives a lot of retrofit activity. And just before Christmas, there was a consultation on this concept of pay for performance. So rather than getting your payout based on a deemed carbon saving, so okay, you've applied external wall insulation to this 3-bed semi, here's 5 carbon credits or whatever. Actually measure before, measure after, show us what impact your improvement, the intervention has had. And that drives quality then, doesn't it? Because you've incentivized the contractor, the energy company, to do a good job, because the after measurement would show that. So it's in their interest to mitigate the thermal bridging and make it look as well performing as possible. So yeah, there's lots of nuance to the measurement thing, I think, around, it's one thing, sort of holding people to the sort of feet to the fire and creating that feedback loop, but it's helping drive quality, and I think helping engage consumers more around, we'll measure and understand the uniqueness of your home to tailor a retrofit package for you and the way you live and the way your house performs. This isn't just fag packet calculation stuff. So it builds trust. Then the whole finance and insurance sector, they are chomping at the bit to plough money into this space, but they need tangible we can put a loan on this property to upgrade it, but we need to know what that loan delivers in terms of measured impact. So the whole idea of carbon credits and again, kind of measured outcomes, measured impact. So the measurement techniques are kind of, we're not quite there yet, but they're going to unlock that whole space, I think.
That's great. I really do have a positive outlook for the future, and that's based on the perspective I've had that when I first set the company up in 2006, people were not interested in most of the things that they're interested in now. Words and phrases and terminologies just were not used back then at all. And so, you could argue it's been a few years since 2006, but that's been significant progress to where we're at the moment. And I just think that the more we can empower and enable the average person to know and understand what good looks like, the more that will help the people that are bringing these components together that we call buildings to figure out pathways and improve quality so that we get what we're after. Because you're right, it's all about measurement, it's all about performance. There needs to be a standard. It's about making it really simple so that I can understand what good looks like, instead of just being flooded with loads and loads of data that's just really confusing.
That's another really important point is it's not measurement for the sake of measurement. It's not data for the sake of data. It's trying to be really objective, clear, black and white. This is the design performance, the measured actual, removing the noise of occupancy and weather effects, and that's the real kind of innovation in a lot of our products. And the bit we haven't touched on is consumers are increasingly empowered. So sort of Internet of Things, sensors, the rollout of smart meters. I think the average consumer is much more plugged into this sort of stuff. So if industry doesn't step up and start measuring these homes, the consumer will, and they'll find a way of finding out what the design was and driving their own kind of conclusions.
Is there anything that you're working on, something that will go into the consumer's hand that will help them understand what all of this data actually means to them?
Yeah, so our HTC method is called Smart HTC, and we've got, if I may say so myself, quite a nice business model around that, where fundamentally it's an algorithm, and so it can be mobilized as a measurement service. So we do equip architects and building surveyors and energy assessors with it. They go into a home, take an opening set of meter readings, put a set of temperature loggers in the home, would return 3 weeks later, collect them up, can report on a measured HTC. We also then work with integrators. So we have an API into this algorithm. So if a smart thermostat provider or a manufacturer of an in-home display for smart meters has a stream of energy data from the utility meters and a stream of internal temperature data, they can call our algorithm and return a value. And then we have actually just done a version of Smart HTC that will drive purely on smart meter data alone. So then you've got the prospect of working through just an app, basically, and connecting in your smart meter. And so, yeah, through the latter channel, the kind of integration approach with other devices in homes, we're not talking about sort of fancy instrumentation and extra hardware and kit that needs to go in. We're talking about this stuff's already in homes. People can access it quite readily, whether that's motivated by the manufacturer of the smart thermostat and they want to see, or whether it's the consumer wanting to see it on a heads-up display in the home. And it's just like your dashboard in your car, and you can see your miles per gallon. Yes, already with a smart meter, you can turn your kettle on, and lo and behold, my energy use consumption at that point in time spikes. But what if you've also got on that display the thermal performance of your fabric is X, and this is how it's tracking over time, or this is how it is relative to how it's otherwise predicted. So yeah, there's so many different kind of ways in which this is going to manifest in the industry. Something else we haven't touched on is EPC reform. So that was another consultation earlier this year. The future of EPCs, it has been touted, will be premised on maybe this kind of sliding scale idea of being really clear with the consumer that you've got predicted performance and here's your A to G rating, and then you've got measured performance and here's your A to G rating based on that measurement linked into your smart meters. Like the technology exists to do that today, this online building passport kind of idea. So again, that just engages more and more people in this subject matter.
Kevin, I think you're doing some great work. I have admired at least Pulse. I've not used any of the other products that you've got, but I've admired Pulse from afar, and we've used it for a period of time. And although as a consultancy we don't do air testing anymore, we've moved away from that, but can really see how it not just provides with more accurate information, but takes a lot less time, and it's a lot more mobile now than what the early prototypes were. So I guess my hope is that you'll just keep doing what you do and keep moving things forward, and just congratulate you for the success that you're having today.
Thanks for having us on.
Thanks for watching to the end. I think that you'll like this, but before you do that, just make sure that you've commented and liked below, and also that you subscribed.